All right, so the main purpose of this video is just to walk you through how to do a dihybrid cross. Before I walk you through how to do a dihybrid cross, so I'm on the biology genetics problems sheet. I'm going to do numbers 1 and then 3 because they're related to each other. And one is going to be a monohybrid cross and one's going to be a dihybrid cross. So first we're going to start with the monohybrid cross. But scientists have learned, so basically you discover a new planet, there are creatures on it called prafts. And what we learn about those prafts is that their eyes can be pink or yellow, and that yellow eyes are dominant to pink. Now, just to point out here, the letter that I've chosen is E, and the reason is if you look at Y can be the same both capital and lowercase, and so can P. So those would not be good choices, just because it could be really confusing when you're writing your work out. So I'm going to go ahead and choose E, and we're going to use a capital E for the dominant trait, which is yellow, and a lowercase e for the pink trait, or the recessive trait, which is pink. So I tell you here then, if two heterozygous yellow-eyed prafts mate, what's the probability of producing a pink-eyed praf? So two heterozygous. So what that's going to tell us is that our parents look like a big E, little e, and a big E, little e. Okay? So each one has one letter. So if we were to map out our Punnett square, we would want to do one on each side so that we end up with a 4-box square. Then we fill it in, big E, big E, big E, little e, big E, little e, and then little e, little e. So our question was, what is the probability? So we're going to want to give a fraction. What is the probability of their producing a pink-eyed praf? And the probability is pink eyes would need 2 little e's because it's recessive. So only this box is going to produce a pink-eyed praf. So we would say little e, little e. The probability of that is 1/4 pink-eyed prafs. And then always put a box around your answer when you're doing these problems just so it's clear for me to see. Okay? All right, let's move on to the dihybrid cross. Okay, so now looking at number 3, we have 2 traits. So we're going to be looking at the yellow eyes, which are still dominant over pink eyes. And in addition to that trait, we're going to look at a second trait, which is their feet. And now these traits are not related in any way. Okay, so having eyes, remember the rule that we're going to talk about with Mendel, independent assortment. If you haven't watched that lecture yet, I'll get there when you do watch the lecture. But independent assortment says having a certain color of eyes does not make you more or less likely to have webbed feet. So this organism, these traits aren't linked. But we are going to examine both of the traits. So we're going to look at yellow eyes and pink eyes with webbed feet and hoofed feet. So let's look at our 2 parents here, and we have to be really careful to make sure that we get our parent genotypes correct. So we have a homozygous yellow-eyed. So let's go look. Okay, yellow eyes is dominant, and homozygous means 2 traits for that. So we have capital E for yellow. And then web-footed. For feet, we're using F. So web-footed is dominant, and we said that they're heterozygous. So that means that this organism has one of each, one capital and one lowercase. So this is parent number 1, homozygous yellow-eyed, heterozygous web-footed praf. Now we're going to mate that praf with a pink-eyed, hoof-footed praf. So pink is recessive, so we know immediately that this one has to have 2 lowercase e's or it wouldn't be displaying the recessive trait. And then it's also hoof-footed, and we can see here that hoofed feet is also recessive. So this animal must be recessive for both traits. Now, you can set up a Punnett square that is 16 boxes for this one. Now, the way that you would do that is to say, what are the possible combinations? So these 2, so we'll take the first 2 of each one. So capital E, capital F is one combination. Then this one, this capital E with this capital F is another combination. This capital E with this lowercase f is another combination. And this capital E with this lowercase f is another combination. Now, if you're saying, but Mrs. Carvalho, that seems ridiculous because some of those are the same, you would be right, okay? I'm just going to show you guys how to set up the 16-box Punnett square, and then I'll come back over here and I'll show you what I would actually do. I just want you guys to understand what you could do if you wanted to make sure that you were correct. Now, we would take this E with this F, this E with this F, this E with this F, and the first E with this F. Those are technically all the possibilities that could be donated. Now, if you were to fill in this Punnett square, what's really important is that you would get 4, ooh, sorry guys, I'm off my lines here. You would get 4 letters in each one. So we would get big E, big F, little f. Big E, big F, little f. Big E, big F, little f. So you fill in your Punnett square like this. And this will sure give you the correct information. But if you're watching me do this and you're thinking, well, that doesn't look like fun, I have better things I could do with my day. Yeah, I'm sure you do. So we're going to try to shorten this process as much as possible. And we can do that by not actually drawing out as many boxes. Well, then the question becomes, well, how would you know which boxes to draw? Well, we're going to go through and we're going to ask the question of what are the possibilities that each parent can donate? Okay, so if you look at this one, the combinations that this parent can donate are big E, big F, or big E, little f. If you look, are there any other combinations that parent could possibly donate? No, because it has only big E's. So it can do big E, big F, or big E, little f. Now looking at this parent, it has a little e, only little e's, and only little f's. So the only choice for that one is little e, little f. So instead of doing that big old 16-box Punnett square, you can just do a 2-box Punnett square. Fill it in. And then let's look at the answer, just to make sure that we get the same thing that we would have gotten if we did this. So the question said, could they have a baby giraffe with yellow eyes and hoofed feet? Well, to answer that question, let's show what would yellow eyes and hoofed feet look like. Well, it would be any combination, anything with a big E and 2 little f's. So this shows us that they have a 50% chance of having a baby with yellow eyes and hoof feet. If this method works, we should see that they would also have a 50% chance. Looky here, there's a half chance of yellow eyes, hoofed, footed. And so we, instead of doing all of this work, we just did this, and we saved a lot of time. All right, if you guys have questions, I will answer more specific questions in the Zoom meetings for this week, but I did just want to show you guys how to do a dihybrid cross. I assigned the problems online, and several of them are dihybrid crosses, so now that we've done this one, I'd encourage you, this one just down here, number 4, is also a dihybrid cross, I believe. If it's not, the next one after it is. But go through and try a couple of these problems, and then see if you have questions before you hop on Zoom.